So this is some example use scenario for the sector file system, right? So it's it's a cheaper distributed file system. It's open source commodity computers, and it doesn't require very expensive hardware. And so, and also sector doesn't split file into blocks. Some people think this is a disadvantage, yeah, because it's actually has a file size limitation because it doesn't split files. They put one single file to a single node, so the file cannot be too large. But on the other hand, because we don't split the file can actually, the sector file is just the real files in the native file system. You can actually open the file outside the sector system, right? You can actually log into the slave node to process the file using other system, right? For example, if you have a workflow system, if you have a grid scheduler, you already work with with these clusters, and after you install sector on it, you just need to use sector to manage your data. You can still run your existing workflow or grid scheduler to process your data outside sector, right? So this is really this is very convenient for many people with legacy applications. But if you install Hadoop on those, you won't be able to touch Hadoop data outside Hadoop. You only can access data with Hadoop API. You won't be able to go to the Hadoop storage system to get the data out because it's not the native format. Because you can also set up the sector on cloud. You can actually start multiple EC2 instances. You can install sector on them. That's pretty straightforward. And this is unique, as we already emphasized, that you can actually run Hadoop, run sector on wide area network. This is important because many of you run national or international collaborations. You have data collect from multiple data center, multiple locations. You don't want to move them into a single location. That's not very productive. Also, I already mentioned that you can actually use sector for this content distribution, and we're already doing that with this Sloan Digital Sky Survey application. This survey basically this is an astronomy project. The astronomers they take the image of the universe images they generate about for example the latest data release contain about something between 10 terabyte to 20 megabyte of satellite image, and all the astronomers around the world, they want to access this image. They want to do their own scientific research. So the problem is how do you give this 20 terabyte image to those astronomers? There's in China, in Russia, India, Europe, Australia. So we set up a system. We put this image data in sector. This is a wide area distributed file system, and any user with a sector client can connect to this system, and they will download a replica of this image from a location from nearby location. For example, if some user from South Korea connect to this system, he or she may download the data from one of replicas in Japan. We have a small cluster in Japan, and with some 50 terabyte of storage on that, and the user can download data from there. So this is just a diagram, about the process I just described. So you can actually run sector on multiple data centers. They connect by high-speed networks, and only user with a high-speed network connection can write and read from the system. So it could be very useful if you have a lot of distributed data. And then again, if you still think that you don't want to spend time to try to install yourself, we have example system we installed in our own test bed. It's called the Sector Public Cloud. You go to this web address, and you can find information how do you access it. Basically, right now this is not big because it's just for testing purposes. We have 2 clusters. One is the Chicago downtown called Starlight Data Center, and the other one is at Japan. It's connect on the JGN to high-speed network. It's 10 gigabits per second high-speed connection. So I think right now there are about 50 terabytes of available disk space in that system. So, and of course, this is a research network. So if you try to log in from home, you won't be able to get in because, and it doesn't make sense anyway because your home network has maybe 5 megabits per second. This bandwidth is not fast enough for you to download terabyte of data, maybe. So if you want to try this from your campus network, your research network, anything that connect to internet to, yeah, that will work. So you can try this out. If you think that's useful, you can try to install a copy on your own. And again, this is a testing system. Sometimes maybe it's done, but just let us know. We will get it up as soon as possible. But it should be running right now. Yeah. So let's go to Sphere. So Bob already talked about that. The Sphere process data stored in sector by running a user-defined function on all the data segments in parallel. Okay, the data segment can be a records, can be a group of records, can be a files, or can be even directories. Right. So no matter what you want to run, basically, for example, if you have 1 billion of images, you want to do an image processing job on this 1 billion of images, you can just pass your this image processing function or binary as a UDF to Sphere. Sphere will run this in parallel and get you back to the result. Right? And we will run the processing on where the data is located, so data is not moved. It's much faster than you copy the image out to another location to run the processing. And I want to mention that there's another big advantage of not splitting files into blocks in sector, right? If your image is big, if, for example, you have you have a very big image, it's 1 gigabyte in size. If you put this image in Hadoop, it's split into multiple blocks scattered on many places. And when you run your image processing job, it doesn't run on a piece of image, it has to run on the whole image. And then in Hadoop file system, somehow you have to read all the blocks into one location, reconstruct the whole image, and do the data processing. But in sector, the image is already in a single location, so there's no data transfer at all. It's much faster. So that is another advantage of not splitting the files. So how does Sphere segment the data? So basically, if your data segment is files or directories, that's natural. You just tell sector that your minimum processing unit segment is a file or directory. But sometimes you have to process records in a file. Well, then you have to do specify a record index, offset index. You have to tell, basically you have to tell sector how to pass your data, because nobody else knows how to pass your data. You are the only person who has the knowledge of the data. So that's very similar to when you run MapReduce job, you need a runtime parser to pass your data. It's a similar process. But instead of a runtime parser, Sphere has a permanent offset index on disk. So you don't need to pass that at runtime every time. So basically, this is an example of UDF. Input, output, and some parameter information. It's very simple. If you have an existing application, you just need to wrap up your binary, call your binary inside this UDF. Just a few lines of code, you can wrap it up. Or if you want to write a new application, you can write that as well. And after you finish the UDF, you just need to specify the input, the output, and run the input, output, and your UDF. This is the name of UDF. And this is how do you specify the segment and the parameters and the parameter size. That's it. That's very simple. And then you wait Sphere to finish your data processing, and you maybe want to do some post processing, and then you log at close. So that's it. But if you think that's the only thing that, I mean, some people think that's the only thing that data parallel application that Sphere can do, but actually Sphere can do much more complicated things. I think, that's almost time. I don't want to kill more of your brain cells, so I will skip these slides. But I will give another example. This is a more complicated example. For example, if you want to join two very big data sets, for example, 200 terabyte data set that scatter all over the place, how do you join it? You actually, it's very simple in Sphere. You scan each data set individually. You have a UDF to pass the data, and then you hash the data according to the key to different buckets, right? Because in order to join the data, you have to scan the keys. You find the same keys. So you throw all the data in the same keys to the same bucket, right? And in Sector, your Sphere, you can actually specify the output location. You can put the bucket from two data sets to the same node, and then you join these buckets. Because they are on the same node, you don't need to move them another time. So this is another data locality for example in Sphere. So it's pretty straightforward. So that's about it. You can find all the information from this website, and I will also put up these slides to the website. And for any questions, you can email me. You can post the question on the project forum. There will be other people to answer, but you can write to me directly if you want. And right now, this is open source project. We have 5 active contributors. We are working intensively to improve the system every day. But if you are interested, you're welcome to join us. So I think I can answer some questions, and Bob can also answer your question if you have. That's a question answer, right? I don't know.
So are there any questions? So I have a question for both of the speakers, namely, when will Sector and Sphere be available on FutureGrid?
We're ready. Jeffrey, we should talk.
Yeah. Fine, we will talk. Good.
We're ready. And then, it's keeping us up at night that we're not there, so I'll be able to sleep better, so the sooner the better.
I really want to make the world happy. I don't like all these unhappy people with lots of friends.